Hello, good morning, everybody. Hope you are all doing well. Welcome back to my class. So, today I'm going to continue on activities about scientific notation. As you may have already known that we are ahead the program. So, most probably the next week will be also activities. I'll try to be back to parallel lines and uh, transversal exponents, back to scientific notations. I will make it like a longer revision because we've already covered almost the whole program of this year. Alright, let's start from the first activity. Match each number from the left, this list here, to its equivalent on the right. So I have few numbers here, some of them written in scientific notation, other written in standard notation. I want to find their equivalent, or the number that is equal in the right group here. Let's start from the first one, 2.4 times 10 to the power of 3. What is this number? It's written in a scientific notation. So if I want to write in standard notation, I need to reduce the power of 3 to 0. How can I reduce it by 3? It is by moving my decimal point here 3 places to the right. So I will add here 2 zeros. So it will be 2400. So the answer is 2400. Now let's go to the second one, 4.2 times 10 to the power of 4. Again, it's written in scientific notation. And in standard notation, I need to move my decimal point 4 places to the right. Why? Because I have here power of 4. So what is the answer here? It is 42,000. So my decimal point was between 4 and 2. I moved it 1, 2, 3, 4 places to the right. Great. What about this number? 4.2 times 10 to the power of 3. Okay, in scientific notation as usual, and I want to move my decimal point 3 places because of the power of 3 here. So how can I move it? 1, 2, 3. So it will be 4,200, which is this one. Now 420, it's written in standard notation. What is its equivalent in the scientific notation? Of course, I'm going to move my decimal point now to the left and increase the power of 10. So I need to move it 2 places. Okay, why? Because we said in scientific notation every time the first number should be between 1 and 10. So I should make it between 1 and 10. The number is 4.2. Now times 10 to the power of what? What is the power of 10? It will be 2. Why? Because I moved it 2 places. So the equivalent number for 420 is 4.2 times 10 to the power of 2. Alright, finally, of course, 4.2 times 10 to the power of 5. It should be this one, but let's see. So 5 in the power of 10. So I need to move my decimal point 5 places to the right. So I will add 4 zeros next to 2. So it will be 420,000, which is basically this one. Great. Now let's move to this list. Now write each number in scientific form. Now look at these numbers, guys. 54 times 10 to the power of 4. Is it written in scientific notation? Be careful. This is not a scientific notation. Why? Because we said your first number here should be between 1 and 10. So how can I convert this number into the right scientific form? This means I will need to move my decimal point 1 place to the left. So I want to make this as 5.4. How can I make it 5.4? I will move it to the left and multiply this number by 10 to the power of 1. So 54 is 5.4 times 10 to the power of 1. You understand how I brought this power from? Once you move your decimal point 1 place to the left, you add 1 to the power of 10. Okay, so 54 is equal to 5.4 times 10, or times 10 to the power of 1. Now, this number times 10 to the power of 4, of course. Now, look at these two numbers. I have the base 10, okay, and I have powers here, 1 and 4. What did we say in the law of exponents? If we have the same base, okay, 10 and 10, I will multiply their exponent. Is this right? No, we will add them. So 10 to the power of 1 times 10 to the power of 4, it is 10 to the power of 1 plus 4, which is 10 to the power of 5. So this number is equal to 5.4 times 10 to the power of 5. The 5 comes from 1 plus 4 because I have the same base here. Now let's go to the second. Is it written in the scientific form? The answer is no again, because this number is not between 1 and 10. I need to make it between 1 and 10. So how can I make it? I need to move my decimal point 3 places, or two places. Moving the decimal point 2 places to the left means I will multiply it by 10 to the power of 2. Alright, so I will write this number as 5.4. Okay, then since I move my decimal point here 2 places to the left, I will increase the power of 10 to 2. So 540 is equal to 5.4 times 10 to the power of 2. Now all this number is multiplied by 10 to the power of minus 7. The same thing now, forget about brackets because it's multiplication, so we can remove the brackets. 10 to the power of 2 times 10 to the power of minus 7. We have the same base, which is 10, so we will add their powers. So 5.4 times 10 to the power of 2 minus 7, which is minus 5. So the scientific notation is 5.4 times 10 to the power of minus 5. Let's go to this third example. 0.54 times 10 to the power of 2. Now, I want to make it scientific. It is not. Why? Because 0.54 it's less than 1. It is not between 1 and 10. So, I will move the decimal point to the left now. To the right, one place. So, if I move to the right, I will decrease the power. Or I will divide by 10. Let's say decrease the power. So, here it is 0.54 times 1, or times 10 to the power of 0, because we said any number to the power of 0 is 1. Okay, now if I move my decimal point to the left, it will be times 10 to the power of minus 1. So 0.54 is equal to 5.4 times 10 to the power of minus 1. Now this number is multiplied by 10 to the power of 2, which is here. Again, the same base. I will add these powers, so it will be minus 1 plus 2, which is 1. So my scientific notation is 5.4 times 10 to the power of 1. Now for these three examples, I'm not going to show this step. I'm going to show directly the answer. You should be quick at reasoning these things. Let's go to this number, 5,400 times 10 to the power of 8. It's not in scientific form. I need to make it scientific. So I will move my decimal point how many places? 1, 2, 3. So it will be 5.4 times 10 to the power of 3 times 10 to the power of 8. So 3 plus 8 is 11. So it is 5.4 times 10 to the power of 11. Okay? If you are confused, go back and do the same process I did here. Put brackets and continue. I'm just going to make it quick for you to get you used to fast calculations. Alright? What about this one? 0.0054 times 10 to the power of 2. Okay, I need to move my decimal point this time to the right. How many places? 1, 2, 3. So if I'm moving to the right, means I will multiply it by 10 to the power of minus 3. Now 10 to the power of minus 3 times 10 to the power of 2. It is minus 3 plus 2, which is minus 1. So it's 5.4 times 10 to the power of minus 1. Finally, 0.054 times 10 to the power of minus 8. What is this number? It's not scientific. How can I make it scientific? I will move my decimal point to the right by 2 places. So this number here will be 5.4 times 10 to the power of minus 2. Now 10 to the power of minus 2 is multiplied by 10 to the power of minus 8. Minus 2 minus 8 is minus 10. So my scientific notation is 5.4 times 10 to the power of minus 10. Great. Now let's go to this activity. This is the list of planets' diameters in kilometers. Mercury has a diameter of 4.8 times 10 to the power of 3. Okay, this is the list of the rest of planets. For example, where is the Earth? The Earth's diameter is 1.28 times 10 to the power of 4 kilometer. Now, we need to order this list from the biggest diameter to the smallest diameter. How am I going to solve this one? How to compare these numbers? You have basically 2 ways. Either you convert these numbers from scientific to standard notation and compare as usual. That's method 1. Method 2, convert the standard numbers to scientific notation, then make your comparison. I will choose the method 2. Okay, first I will convert those who are in standard notation. For example, this one, 12,100. It is in standard notation. I will write it as scientific. How? I'll move my decimal points 1, 2, 3, 4 places to the left. So I will increase the power of 10 to 4. Okay, this is already in scientific. This is standard. How to write it in scientific? I will move my decimal point 3 places to the left. So I will increase the power of 10 to 3. So this is equal to 6.792 times 10 to the power of 3. Okay. This is scientific. What about this one? I'll move my decimal points 5 places to the left. 1, 2, 3, 4, 5. So it will be in scientific notation as 1.205 times 10 to the power of 5. Finally, this number here, I'll move my decimal point 4 places to the left. So we are moving to the left, we will increase the power of 10 to 4. Now, I have all the numbers written in scientific form. Now, how can I compare them? Remember, the question says from biggest diameter to smallest diameter. So first I will look for the highest power of 10 between these. 3, 4, 3, 5, 5. Okay, so I have here 10 to the power of 5 and 10 to the power of 5 here. They have the same power. I will go to the number and compare the numbers. Forget about 10 to the power. So 1.4 and 1.2. Which one is bigger? Of course, it's 1.4. So Jupiter has the highest or the biggest diameter. So Jupiter is the first one. Now Saturn will be the second. Now I'm done with power of 5. I will move to power 4. This number is to the power of 4. This one is to the power of 4. What else? This one is to the power of 4 and this one is to the power of 4. Now I have 1.2, 1.28, 5.11 and 4.9. So 5.11 is bigger. So this will be the third. So Uranus will be 3. Okay. Now below 5.11 I have 4.9. So this is the fourth one. Okay. Now this is 1.28. This is 1.2. This is higher. So this will be the fifth one. And this is the sixth one. Now I'm done with power of 4. Let's move to power of 3. How many power of 3s do we have? We have Mercury, we have Mars, and we have Pluto. Now I have 2.3 here, 6.7 and 4.8. So 6.7 is the higher. So this is the seventh. Alright. Now this is 4.8 and this is 2.3. 4.8 of course is bigger, so this is the eighth one. Finally, Pluto is the smallest diameter between these. So the order of planets is number 1 Jupiter, then Saturn, then Uranus, then Neptune, then Earth. The Earth is the fifth. 6 is Venus, and 7 is Mars, 8 is Mercury, and 9 is Pluto, which is the smallest one. Now, how big is the diameter of Jupiter compared to Earth? This is the diameter of Jupiter, and this is the diameter of Earth. I want to know how much Jupiter is bigger than Earth in diameter. So what I'm going to do, I will divide Jupiter diameter by the diameter of Earth. That's what I did here. 1.429 times 10 to the power 5 divided by 1.28 times 10 to the power 4. So in division of scientific notation, we said we will divide this number by this number and multiply the power by the power. Alright, so 1.429 divided by 128 is 1.116, almost. Then 10 to the power of 5 divided by 10 to the power of 4. Remember the law of exponents. The same base here, so it will be 10 to the power of 5 minus 4. Okay, we do subtraction. 5 minus 4 is 1, so this will be times 10 to the power of 1, or times 10. And this is equal to 11.16. So I'll move the decimal point one place to the right. 11.16. So the Jupiter diameter is about 11 times bigger than the diameter of Earth. In fact, if you look at this picture here, this is Jupiter, the biggest planet in our system, and this is the small one is Earth. Okay, the diameter, which is this distance from here to here, of the Jupiter is equal to 11 times the diameter of Earth. In fact, if you put Earths next to each other, you will find almost 11 Earths around here, which is very big. Now, there is another question. One of you will answer it and you will get 5 plus points. I will look at the first one who answered it and you will get 5 plus points. The volume of Jupiter is bigger than the Earth about 1,331 times. Why? Here we said the diameter is bigger by 11 times, but the volume is bigger by 1,331. So basically what does this mean? It means you put 1,331 Earths next to each other to get the volume of Jupiter, which is big. Okay, the first one who answered this question will get plus 5 points. Finally, this is a homework, funny homework. I want you to scan these QR codes. Each QR code will lead you to a website page. In that website page, you will find an answer of one of these questions. You get that answer, you write it in standard notation and in scientific notation. For example, what is the average mass of an adult housefly in kilogram? Okay, this is a question and its answer is in one of these pages. You should scan them and check them. What is the current population of the world? You'll find it in one of these websites. What is the estimated volume of the ocean in cubic miles? I want you to give me the answer in cubic miles. Again, it's in one of these websites. After you find it, write it in standard here and in scientific notation. The last one, what is the closest distance between USA and Russia in miles? Alright, thank you so much for today's class. This is my virtual class. For those who did not join, please join and upload your homework there using this class code. Take care of yourselves, sleep tight, keep yourself safe, use sanitizers. See you tomorrow.